Okay, there is a complex number u, which is 2 iota. Can I write this 2 iota as 2 into cos pi by 2 plus iota sine pi by 2? Yes? Or even I can write it as 2 cos 90 plus iota sine 90. I'm writing it in polar form because I have to find this uw and u over w. And you know that this can be done very quickly if your numbers, they are written in polar form. Now your w is already given. We have given its argument. We've given its modulus. So w is 1 into, that is cos 2 pi by 3. Let me write it as cos 120. This will help us to find their sums and differences quickly. So I'm writing them in degrees intentionally. Okay? You see that because of writing them in this form, I can quickly write UW. Yes, guys, what will be UW? What will be the modulus of UW? When you multiply two complex numbers in polar form, the product's modulus is the product of the moduli of those two complex numbers which are being multiplied. Okay, so this will have a modulus. You see, its modulus is 1 and its modulus is 2 here. So this will have a modulus which is 2. What will be the argument? You will add them up. Okay, so this will be cos 210 plus iota sine 210. Now, am I doing something wrong here? Remember, your argument cannot exceed 180 or it cannot go below minus 180. So this 210 is actually, it is going to go like this. This is your 210, okay? So this is up to here, this 210. So this is 30 degrees over here. So this 210 actually means minus 150. It is minus 150. So you will rather write it as 2 cos of minus 150 plus iota sine of minus 150. Okay? When you divide them, u over w. So what will be the modulus of u over w? Yes? Resham, u over w is modulus 2 over 1. And that is 2. And what will be the argument? 90 minus 120, that is minus 30. So this is cos of minus 30 plus iota sine of minus 30. That's it. So you see, we have done this so quickly only because of the polar form. So he was asking for the for like them in this form, x plus iota y. So we should listen to him, otherwise he will not be giving us marks. So this can be written as, what is cos minus 150? Tell me quickly, is that under root 3 over 2? I think that is half. Okay, so this is 2 into minus under root 3 over 2, and this will be, and this will also be in minus iota half. So this is going to be minus under root 3 minus 1. That is your UW in the required form. Okay? And this UW, U by W, this is 2 into under root minus under root, no, so this is under root 3 over 2. And this is minus iota 1 over 2. So this U by W is under root 3 minus iota. Guys, you must have questions, bacho. Please ask me if there is any question. If you don't have any question, I have to proceed then. Okay, I'm moving on to the second part. It says, sketch an Argand diagram showing the points U, A, and B representing the complex numbers U, W, and U over W. Okay, so we have all these three numbers here with us. So let me make some space here. Okay, so I have to sketch an Argand diagram. So here is the imaginary axis, and here is the real axis. You should mention that this is the real axis, this one is the imaginary axis. It has got marks, okay? So it says U has to represent U, which is 2 iota. 1, 2. This is 2 iota. So this is U over here, okay? Then this A is going to represent UW. UW is minus under root 3. This is, sorry, here it is minus under root 3 and minus 1. So here is the point A, okay? And U by W is under root 3 minus iota. So here is the point B, okay? So let's join them together for the third part. It says prove that this triangle is an equilateral triangle. How can I prove that this is an equilateral triangle? Yes, Bachu? The easier way is you can apply all your coordinate geometry rules onto these complex numbers. You can take this point as 0, 2. This point is as under root 3, minus 1. And this point is minus under root 3, minus 1. And you can show that the distance AB is equal to distance BU, that is equal to distance AU. Now that is for the general public. The mediocres would do that, okay? The ones who are the toppers, they should look at this method, okay? Since we've already written them in their polar form, what is this is basically your A and this is basically your B. Now what is the modulus of this if I call this OU? Isn't this length, isn't it 2? Isn't this 2 as well? Isn't it 2 as well? All of them have the same modulus, which is 2. Modulus means the distance of the point from the center, the distance, the point which is representing that complex number. Okay? Now, do you remember that this angle is 30 over here? Let me change the color, which color I should use here, maybe pink. Okay. Now this angle is 30 over here. So how much is this angle? 120. This angle is also 30 here. So how much is this angle here? 120. And this angle is also going to be 120. How is it going to help you to prove that this is an equilateral triangle? The hint is the rotational symmetry. An equilateral triangle has a rotational symmetry of order 3. And if the rotational symmetry order is 3, then the angle of rotational symmetry is going to be 120 degrees. So the great people would say that OU, OA, OB, they are all equal to 2. Because you see, you can say this modulus is 2, this modulus is 2, and this modulus is 2. And the angle between all these, I can say them diagonals here, these lines here meeting at the center, they have the angle 120, which is the angle of rotational symmetry of an equilateral triangle. Okay? So, going back, this